So here's an equation. So what I want to know is from this equation, what can you tell me about the graph? Okay, Amy.
It's decreasing.
Okay, so we know the graph is decreasing. How does Amy know the graph is decreasing? Paige.
Because it's a natural log.
It's a natural log. So we know it's a natural log, the graph is decreasing. So those are things that I want you to be thinking about. Okay, now, what type of model is it? So from this, we know it's decreasing. And we know it's decreasing because we took the natural log. Okay. And now, what type of model is it? You guys, we've only studied one type of model, so it's exponential. So, you know it's decreasing, you know it's a decreasing exponential model because we took the natural log. If we are going to do where we take the natural log of both sides, but right now all I'm focusing on is this. So this is one transformation. So what we've done to our data, right, it was a decreasing exponential model. We've linearized it. This is our linearized equation. It is a least squares regression line. That is what we've created, but it's linearized. So what do we have to do to it now to make it so it fits our decreasing exponential model? So what do I have to do to it? Sophie knows. I'm just joking. What is the inverse of natural log? E. So am I going to do it to one side or both sides? So we're going to take E of both sides. And you guys, let's go ahead. For the one thing I did that you do need to do is you do need to put that y hat because it is a prediction line. Oh, I guess you need to use your calculator. And you guys, make sure you do the second ln. Make sure it's not ln. Make sure you hit second ln. So for everyone at home, I hit second ln right here, and then I'm going to type in -2 because that's what I have it as, okay? So e of -2, e of -2, and I get what? What did you guys get? Okay, here is another example, okay? This is probably going to be our last exponential model for today, and then we're going to do some power models. Okay, so is this an exponential model or another model? It's still exponential because we only took the logs of one side. Okay, so is it increasing or decreasing?
Increasing.
It is increasing. How do we know it's increasing?
It's log.
Because we use the log. So ln is for a decreasing exponential model. Log is for an increasing model. Now, we know that we need to transform it. So this is what we did. We took our data and we linearized it by taking the logs of the response variable. So let me say that again. What your calculator did was we took the log of the response variables, and we did a least squares regression line on the explanatory versus the log response variables. And they linearized it. So this is what we got. This is a least squares regression line. We took that data and we made a straight line. But that doesn't help us, right? All it did was linearize it. Our data is not linear. Our data is nonlinear. And because our data is nonlinear, we need to transform it so that we can make it into the equation that matches our data. So we're going to transform this now. What is the inverse of log? 10. So we're the inverse of log. To get rid of a log, you do 10 to both sides. So it's 10 log y hat. Okay, so again, I just want to make sure that we understand. So we had data. It was increasing and it was nonlinear. We noticed that it was an exponential because it was increasing by the same step. So we took the log of the response variables. This isn't anything that you're going to have to do, but you have to understand what they did. They saw this picture, they took the logs of the response variables, and they came up with the least squares regression line. So the least squares regression line was based on x log y. Okay? That's what your least squares regression line was based on. So when they went to graph it, you guys, the explanatory variable was along the x-axis, the response variable was on the y, but instead of it just being plain y, now it's log y. And then they did the least squares regression line, and they came up with this. Now, what we're doing is we're transforming it back into the equation to match the original data. So in order to do that, we have to get rid of the log. And the inverse of log is the 10. So these are going to cancel each other out, and we're going to be left with y hat. Now, in our exponent rules from way back in algebra, if you have the same base, you can add the exponents. So I'm going to do 10 raised to the negative 1.89940. And then that's your equation, okay? You can use this equation to predict, or you can use this equation to predict. And that's what they'll ask you, like multiple choice questions. They'll ask you, what is this prediction? The only thing that you have to make sure that if you use this equation to do the prediction, that at the end you do the inverse. Okay? Like because they will give you, they're going to bank on the fact that you're going to use this equation to predict, and you're going to forget to take the logarithm or the inverse, right? They're going to bank on that. So they're going to give that as an answer. You're going to plug it in, you're going to forget, oh my gosh, I was supposed to take the logarithm, or I was supposed to do the inverse. So just make sure that if you use this equation to predict, that you actually do that log, you do the inverse, okay? And you can plug it in and do exactly what we did, or you can use that equation at the bottom to predict. So what do I need you guys to take away from here? Okay. So let's make sure we know what you're supposed to take away. Can I take this away? If you see something like that, that means it was an exponential model. So if you see x ly or x log y, you know those are both exponential models. That's the first takeaway. Second takeaway, you know that if it looks like that, you took the exponential model, you took the nonlinear data, and now it's a straight line. It should be a straight line if you see these ordered pairs. This one, you should know that this is a decreasing model. And this one is increasing. And you also need to know that this is what your final equation looks like for an exponential model. And you guys, your x is your exponent in an exponential model. Does that make sense? That's how I always remember it. Every year when I go back to do this, I always think, okay, my exponential models, my x is my exponent, so that's why it's an exponential model. And those are the things that I need you to take away from. And I also need you to be able to transform an equation from the natural log or the logarithm into a new equation. Those are the things that I need you guys to do. How do you feel right now about that? Good? You guys are like, whatever. It's okay. I got it.